Alrighty, in this video, we are going to be talking about the net change theorem. And basically, it's going to be very similar to the fundamental theorem of calculus part 1 in terms of taking the integral, so from a to b of big F prime of x dx. So this is my rate of change. That's going to be equal to big F of b minus big F of a. Essentially, it's going to help us with accumulation models in terms of what we are given and what we are being asked to find. So this right here is the same thing as this, but I just flip-flopped it. I like this version better just because I can visually see that f of a is going to be my starting point. So what I'm already given in this case. And then this part is just essentially what I need to add more to get f of b. So my starting value of f of a plus the integral from a to b of f prime of x, aka my area, is equal to f of b. All right, so looking at number 8, we want to find f of negative 2. Remember that my a value is going to be my lower limit, and my b value is going to be my upper limit. Looking at the problem right here, it tells us that f is continuous and differentiable, so that's good. We have f prime of x, and then we have that f of 4 is negative 2. This means that negative 2 is going to be my lower bound, and 4 is going to be my upper bound because negative 2 is less than 4, which means I'm going to have f of negative 2 plus the integral from 2 to 4, f prime of x dx is equal to f of 4. We don't know what f of negative 2 is, but we do know that the integral from negative 2 to 4 is just the area from negative 2 and 4. If I were to calculate that, the area of my left, it would be 1/2 negative 1 times 2, which is just negative 1. This area right here is just 1/2, 4 times 1, or 2. Which means that my accumulation would be positive 1 from negative 2 to 4. So this means that f of negative 2 plus 1 is equal to f of 4, and we know that f of 4 is negative 2, which means that f of negative 2 is equal to negative 3 once I subtract 1. Okay, number 9, I want you to try this on your own before I'm continuing on with the video. So pause here and then we'll see what f of 6 is. All right, so to find f of 6, I know that my lower bound is going to be 4 because 4 is less than 6. So f of 4 plus the integral from 4 to 6 of f prime of x dx is equal to f of 6. We know that f of 4 is negative 2. And then my area from 4 to 6 would be 1/2 to 2, which is just 2. That's going to be f of 6, and then you'll see that f of 6 is just going to be 0. All right, number 10. We have g being the function given by g of x is equal to the integral from 3 to x of t squared minus 5t minus 14 dt. What is the x-coordinate of the point of inflection of the graph of g? Now remember that point of inflection is basically g double prime. So essentially, we're going to set g double prime equal to 0 and see what's happening here. So to do that, we got to find g prime of x. And g prime of x is going to be the derivative of this lovely thing, aka using the fundamental theorem of calculus and thinking about the last video, we are going to get to x squared minus 5. X minus 14. So me just substituting in x. Now g double prime of x is going to be 2x minus 5, just taking your simple derivative, and then we're going to set that equal to 0. And remember, with a point of inflection, we want a sign change. So here at 5/2, this is just a basic linear function. So it's going to look something like this. And if it's a basic linear function, we have a negative here and a positive here. And since we have a sign change, then we know that the x-coordinate of the point of inflection is basically 5/2. Number 11 is just a basic review from definite integrals here, if I were to do that, and I'm not going to explain why, but it should be answer choice C. So figure out why it's not C in terms of what you're given for A, B, and D, and the givens. Okay. So, we are given the graph of a piecewise linear function, and for number 12 and 13, we're going to see what the difference is between f prime and f. Well, for number 12, we are given f prime, and then for 13, we're given f of x. For number 12, since we are given the integral from 0 to 12 of f prime of x, we could use the first fundamental theorem of calculus to say that this is going to be equivalent to f of 12 minus f of 0. F of 12 is -4. F of 0 is 4. That's -8. For 13, because we are given the integral from 0 to 12 of f of x, and this is already f of x, we're just taking the area from 0 to 12. So we're going to find out what this area is, what this area is, and what this area is. Okay. So I'm not going to write the integrals, but you should know what they are in terms of this right here. This one right here, we have 3 times 4, which is 12, divided by 2 is 6. Just kidding, that is not 3. That is actually 4, huh? So 4 times 4 is 16. 16 divided by 2 is 8, so we have 8 right here as my area. For this part right here, we have 1, 2, 3, 4, and then a height of 1, 2, 3. So that's going to give us 4 times -3, or -12. Divide that by 2 is -6. And then we have this one right here. That's going to be 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. And since it's below the x-axis, it's going to be -16. Then we're going to have it because it's a triangle. So this is going to be -8. 8 minus 6 minus 8 will give us -6. So what's the difference between 11 and 12? Well, not 11 and 12. I should say 12 and 13. Well, 12 uses the fundamental theorem of calculus, as we saw here, because we needed f, our function value. Then 13 just uses basic area because we need big F. But in order to find out what big F is, that's us finding the area. Okay. You guys can do 15 on your own. I'm going to set it up, and then hopefully you guys can just plug this into your calculator because it is calcactive. Okay. So we have g of 2 being -7, and we want to find the value of g of 5. Since 2 is less than 5, we know that g of 2 is going to be my starting value, so I'm going to accumulate after 2. So I have g of 2 plus the integral from 2 to 5 of g prime of x dx. That's going to be equal to g of 5. So what you're going to be doing on the calculator is typing this lovely thing and then finding out what g of 5 is. Remember, on the AP exam, you want to round to the nearest thousandths. So if you were to do this on the calculator, and hopefully you do, 13.899. Okay. Now that we have talked about the fundamental theorem of calculus, part 2, we can compare this with the particular solution that we did back in day 1, where we took the antiderivative and then we used substitution to find out what C is, and then all of that good stuff. So, 16a says find the particular solution of if f prime of x is equal to 3x squared plus 2x, and f of 2 is equal to 3, then use a particular solution to find f of 1. And honestly, I think this is going to be the easiest method in terms of the work, maybe. So here we have f prime of x, so that means f of x is going to be x cubed plus x squared plus c. We're given that f of 2 is equal to 3, so I'm going to substitute in 2 for x and 3 for f of x plus c. So 3 is equal to 8 plus 4 plus c. 3 is equal to 12 plus c. Then c is equal to -9. So now that we know that c is equal to -9, I know that f of x has a function of x cubed plus x squared minus 9. And to find f of 1, that's me substituting in 1. So that's going to be equal to 1 plus 1 minus 9, or -7. And then take a lot of steps there. And at this point on the quiz/test, it's going to ask you what method to work on. So I might ask you to find the particular solution using integrals here without using the fundamental theorem of calculus. Or I might ask you to actually do it using the fundamental theorem of calculus. We have f of 1 and we have f of 2. Since f of 1 is less than 2, we know that we are going to have f of 1 as my accumulating. Okay, what we're going to have to find first. Plus the integral from 1 to 2 of f prime of x dx. And then this is going to be equal to f of 2. All right, so this right here is essentially f of 1 plus 1 to 2, 3x squared plus 2x dx is equal to f of 2. We are going to take the integral of 3x squared plus 2x, which is x cubed plus x squared, and why did I write like that? X squared, and then my bounds are going to be from 1 and 2. So now I have f of 1 plus this thing right here, so that's going to be 8 plus 4 minus 1 plus 1. That's going to be equal to f of 2. 8 plus 4 is 12. 12 minus 2 is 10. So I have f of 1 plus 10 is equal to f of 2. We know that f of 2 is 3. So when I know that f of 1 plus 10 is equal to 3, f of 1 is equal to -7. So 16 just tells us that we have two methods. Either use a particular solution that we learned back in day 1 or using the fundamental theorem of calculus. Whatever method you prefer on your homework or on your tests, fine. However, if it's on the FRQ and we ask you to find the particular solution using one method, then you better use it using that particular method. All right, to end class, we will be talking more about the fundamental theorem of calculus by practicing FRQs that have been released. So that's what we will be doing in class.